Hello students, today we will start with the topic addressing modes in 8085. So let us see what's written in this topic. In the next chapter, instruction set of 8085, you will study all types of assembly level instructions. So as we know that 8085 microprocessor has total of 74 instructions. So all those 74 instructions we will be learning in detail in chapter 2, whose name is instruction set of 8085. An instruction is not recognized by microprocessor, but it understands only binary code. So as we know that computers understands only binary language. This binary code is known as machine code. So what happens is, as I have discussed this in one of my video, that for example this instruction we have discussed many of the time, add instruction. For example, I have instruction add b. So I will not be giving the instruction by typing the characters a d d space b for microprocessor 8085. Instead, add b instruction has specific hex code. I had shared the hex sheet with you like this. See, add b. This add b has hex code 80. So as an input, I will give 80, not add b. I will give 80. This is hexadecimal number. But if I'll give the number in hexadecimals, the processor will convert it into binary. It will do its operation and it will show the output in hexadecimal. So an instruction is not recognized by microprocessor, but it understands only binary code. Assembly level instruction is indirectly converted into binary code that is known as machine code. Instruction may be 1, 2 or 3 byte in length. So now what it means? I'll share with you the first practical of CS2. The first practical is write a program to do addition between two 8-bit numbers. Two numbers are stored in location 2030H and 2031H. Store the result in 2032H. So what is happening is basically in here in this program it is adding two numbers. So for that the set of instructions are written to perform the task of addition of two numbers in microprocessor 8085. So as you can see, this instruction, I will tell you later what this instruction means. LXI H, 2030H. So let us see the hex code of LXI H, 2030H. Okay, I've told you that in hexadecimal number, one digit represents 4 bits. So as you can see, it is 2030H. This is a number. So this digit represents 4 bit, this digit represents 4 bit, this digit and this digit. So 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 2. So 16 bit. So LXI H, 16 bit. This means LXI H, 16 bit. When I look into hex code, I will find LXI H, 16 bit. So let us see here LXI H, 16 bit. The hex code for LXI H, 16 bit is 21. So can you see this is 21 and this is lower order byte 30 and upper order byte 20. Okay. So since these are also hexadecimals, that means one digit represents 4 bit. So 4 plus 4 is 8. 8, 8, 8. 1 byte is equal to 8 bits. So this instruction LXI H, 2030H is of 3 bytes because 1 byte, second byte and third byte. So what it means over here, we'll discuss this practical in a separate video. Just my motive was to tell you what it means. Here it's given. What does this mean? 1, 2 or 3 byte in length. Instruction may be 1 byte, 2 byte or 3 byte in length. So I hope it's clear to you what it means here. The first byte shows the operation type. One more thing I want to tell you. I will take the same example. What are operands? When I perform, for example, addition, like if I do 2 plus 3. So this is 2 and 3 are operands. 2 and 3 are operands. And plus is operator. Got it? So operands are on which we are performing an operation. So as you can see, mnemonics, this mnemonics is bifurcated into two, opcode and operand. Opcode means instruction and operand means the data on which we are performing the operation. So here operands are H, 2030H. H and 2030H are operands and LXI is opcode. So here the first byte shows the operation type to be performed. Of course, the first byte shows the operation to be performed. If I will give 21 as an input in the processor, it will come to know that it has to perform LXI H, 16-bit operation. So the first byte shows the operation type to be performed, that is opcode. Here it is written operand, which is wrong. It should be opcode. And second and third bytes of instruction indicates either the operand or address of the operand. So second and third byte represents either the operand or address of the operand. Now I will tell you, see operand, do you know, by now you know what is operand. I will tell you the meaning of address of operand later. Address of the operand, what it means actually. Okay. So there are number of instructions which are classified according to the type of addressing the data. The instructions are classified according to how the data is addressed. So we'll come to know what is addressing the data. Just keep in mind that the instructions are classified into 5 categories, 5 types: direct addressing, register indirect addressing, immediate addressing, implicit addressing. Let us see each type of addressing mode with example. So what direct addressing is? So the direct addressing mode, the address of the operand is specified within the instruction itself. So we'll come to this later. Let us see the example. LDA06C2H. LDA 06 C2H. This is D. What is the meaning of this instruction? It means load. Okay, before explaining you this, just assume that this is a location, this is a memory location. As you can see in here in this example, each instruction is stored at a particular memory location. See, instruction is stored at particular memory location, and data can also be stored at a particular memory location. So this is a memory location 06C2. H represents hexadecimal. So 06C2 is a memory location. So at memory location 06C2, just assume that 08 is stored. At location 06C2, 08 is stored, 08H. H represents hexadecimal. So the meaning of LDA 06C2H is load the contents stored at location specified into the accumulator. So what it means is the data which is stored at location 06C2 will be loaded in the accumulator register. So in A, what will be there? A is equal to will be 08H. Easy? Now here you can see, as you can see here, the address of the operand is specified within the instruction itself. So we can say this is an operand. This is the actual data on which I have to do the operation. The address of the operand, as you can see, the address of the operand is specified within the instruction itself. Within the instruction itself, the address of the operand is specified within the instruction itself. So those instructions in which the address of the operand is specified in the instruction itself falls under direct addressing mode. Let us see what's written here. For example, LDA06C2H. This means load accumulator with the contents of memory location 06C2H. I hope it's clear to you. Here all instructions are 3-byte instruction. I had taken an example of Alexa H,2030H. Similarly, this LDA06C2H is 3-byte instruction. In this category, direct addressing mode, the instructions, all instructions are 3-byte instruction. Let us see how LDA06C2H is 3-byte instruction. LDA06C2H is a memory location, and each in hexadecimal, each digit represents 4 bit. So 4 digits of hexadecimal means 16 bit. So we will look for LDA 16 bit in hex code table. LDA 16 bit, it's 3A. So this 3A hex code is of 1 byte. This is of 1 byte. This is of 3A H. This is 1 byte. Then lower order byte, which is C2 H, and upper order byte, which is 06 H. So 1 byte plus second byte plus third byte. 1 plus 1 plus 1 is 3 bytes. So that is why all instructions are 3-byte instructions. Another example of direct addressing is STA08B2H. STA is opposite of LDA. So let us see what it means. STA08B2H. STA 08B2H. Here assume that in accumulator 04 is stored. So STA instruction means store the contents of accumulator into the address specified in the instruction. So this is opposite of LDA. So at location 08 B2H, the data which is stored is 04H. After executing the instruction STA08B2H, the data of accumulator will be stored in the location specified. And again, let us see STA 16-bit, hex code of STA 16-bit. See, STA 16-bit 32. So hexadecimal, the hex code is 32H, lower order byte, upper order byte, so total 3 byte. Store contents of accumulator at this location. That is what is illustrated here in this example, here in this figure. So direct addressing mode is what? In direct addressing mode, the address of the operand is specified within the instruction itself. Here, address of the operand is specified within the instruction itself. Here I had to tell you the address of the operand. Now you know what it means. I had told you I'll tell you later about this address of the operand. I hope it's clear to you. Address, what is the meaning of address of the operand? Operand is a data on which operation is to be performed. So let us see what's written here. The first byte shows the operation type to be performed, which is opcode. This too I hope it's clear. And second and third bytes of instruction indicates either the operand, that is data, some data, or address of the operand. So I hope it's clear to you what is address of the operand, data on which operation is to be performed, because at this particular address the operand will be stored. Operand, or the another term for operand is data. So data on which operation is to be performed. Either the operand, what it means, either the operand like, I'll tell you what only operand mean here. For example, you know, I have discussed this instruction several times, move instruction. A comma B, for example. Just assume that in B register 0E is stored, 0EH. This is hexadecimal number. So the meaning of this instruction is move the contents of B register into A register, and the contents of B register will be unchanged. So A will be equal to 0EH. The contents of the B register will be as it is. And there is instruction MVI. It means, for example, MVI A comma 0EH. That means the content is, the operand is directly specified. 0E will be copied into A register. So A is equal to 0E. So direct operand is directly specified. Second and third byte of instruction indicates either operand or address of the operand. Address of the operand is clear to you. So let us see what is the hex code for this. MVI A,0EH. 0E is 8-bit data. So MVI, 8-bit we will see in the hex code. Let us find out. 8-bit means 1 byte. So MVI A,1 byte is 3E. So it is the hex code for MVI, 1 byte is equal to, what was it? 3E. And then we will take this operand which is directly specified in the instruction, 0E. So what is the length of this instruction? The length of the instruction is 2 bytes. So that is what it means here is second and third bytes of instruction indicates either the operand. Okay, the second byte indicates the operand. First byte of course indicates the opcode, the operation to be performed. I hope it's clear now to you. Next is register addressing mode. Let us see what's there in register addressing mode. In register addressing mode, the register name is specified in the instruction. We'll come to that here later. Address is not required for this type. This is register or accumulator register transfer. So first we'll see the example. Same example is given in the textbook, move A, B. So as we had assumed that in B, for example, 0E is stored. So what this instruction is going to do, it is going to copy the contents of B register into A register and contents of B register will be unchanged. So as you can see, register name is specified here in the instruction. So in register addressing mode, register name is specified in the instruction. Address is not required for this type. Can you see, have you seen any address over here? Is there any address? No, like this had address. Can you see, is there any address? No, address is not required. Address is not required for this type of instruction. In this instruction, what exactly is happening is register to register to register transfer, or we can do is accumulator to register transfer. Instead of writing move B, I could have written instead of writing move A, B, I could have written move B, A, and let us assume that A has some value as 0 F H. So what this instruction is going to do, it will copy the contents of accumulator in B register. So B register will be equal to 0 F H and the content of accumulator will be same, 0 F H. So this is register to register or accumulator to register transfer. So this is accumulator to register transfer. These are single byte instructions. Why? Because there is no address, no operand is directly specified. So we will find the hex code of move B, A from the hex sheet. let us see move B, or we can take move A comma B also. We will see move A comma B. Let us see the hex code of move A comma B in the hex sheet. Here it is, move A comma B is 78H. 78H. So this is the hex code. Nothing else is required here because no address, no operand is directly specified. So this is only 1 byte instruction. So the instructions which falls in register addressing mode are of lengths 1 byte. These are single byte instructions. It is very nicely explained with the figure. Move A comma B, move contents of B to A, contents of B register to accumulator. Another example is add C. Add C. What it means, add C. Add C means add C. C is a register. Just assume that C has some value as 02 H and accumulator has some value as 05 H. So the meaning of add C is this. Many a times I have explained the same instruction, only the register is changed. We have seen the example of add B. Here instead of B, C is given. It means A is equal to A plus C. That means contents of C register will be added with the contents of accumulator and the result will stored in accumulator itself. So accumulator is 05 and C is 02. If this is H, A is equal to, so A is equal to 07 H. So the contents of accumulator will be changed from 05 to 07 after performing the add C instruction. So in register addressing mode, add C instruction falls under register addressing mode because register is directly specified here. The contents of register C, add contents of register C to accumulator. Okay. Here transfer is from register C to register A. So we will continue the third addressing mode, register indirect addressing mode, in next video. For today we will stop here. Thank you.